Hello, everyone. We are the Tensor team. Our members consist of myself, Adam, Marcel, Blake, Derek, and Nathan. Over the past semester, we have been collaborating with Pacific Northwest National Laboratories to develop a high-level C++ interface over MPI RMA called RMAX. Throughout this sprint, we mainly focused on two issues. One being the redesign or reimplementation of a better instance for the handles class, and two being the creation and implementation of a debug branch to help further understand and implement better test cases as well as streamline the process. Before we get into that, however, here's Marcel to talk about test cases and some of their applications.
Hi, my name is Marcel, and I'm going to be demoing our debug branch today. Our goal with the debug branch is to just kind of get an understanding of the control flow and the data flow of our program, as RMAX has a really large prototype that pre-exists us, and also an API that's not very understandable if you're looking to get into any of the nitty-gritty. And so as we develop, we want to make sure that we have a consistent understanding of what's going on. Most debug statements right now look a little bit like this, where they mostly just log information about the function call itself, such as where it's located and its name. But with time, we want more and more function debugs that look like this, where we have actual information relevant to the function, in this case, the count that's being filled here. And if we look at it in a test case here, we can see that if we run it just as is, it will compile as is completely normally. But if we include a definition for debug, it will, easy enough, include a bunch of debug statements. And while this may be a little bit harder to read the actual output, it does give some useful insight into where the operators are being called and how that hierarchy works, which is part of the stuff that we're trying to revamp actually in this sprint as well. So it comes in handy a lot.
Hi, I'm Blake and I'll be discussing the handles replacement for RMAX. Firstly, I'll talk about the problems with the current handles class implementation, then I'll discuss some of the things we plan to do or are looking into to make it better. RMAX has two big problems with its current implementation. The smaller issue is that handles is currently large and poorly designed, lending to it being difficult to understand and having a large amount of computational overhead. Furthermore, the larger issue is that handles currently stores information as it receives it, lending to it storing information all over the place in RAM instead of contiguously. This can result in RMAX having potential memory leak issues. In order to fix these problems, we are planning to completely redesign handles. We're currently designing a prototype that takes advantage of the standard async and standard future libraries to help limit the computational overhead and make it easier to understand what's actually happening. We're also planning to look into the C++20 ranges library to hopefully make things even more straightforward. Now, I'll pass it off to Derek to discuss the debug team's work.
One of the key improvements we began to implement to RMAX this sprint was a debug version of the interface. Our goal with implementing this debug version is to further our understanding of this very dense and sometimes difficult to understand codebase and provide users with an invaluable tool for diagnosing their own issues that may arise. Since RMAX was designed with the intent to reduce overhead in terms of running time and memory allocation, there are a lot of anti-patterns that would normally be considered bad coding practices that make it extremely difficult to read and understand, especially for the uninitiated. Some of these anti-patterns include extremely sparse commenting, reused function and variable names, and the use of pre-processing statements to trigger key function calls. We are still very early in the development process of this debug version, but we have begun by adding in marker print statements that indicate which function is being called, which file it is located in, and approximately which line the function definition is located on. We have also begun to add in print statements where we think data is being manipulated to see what the data looks like before it is used and what it looks like after it is used. These print statements are triggered by a preprocessor variable called debug and will only execute when debug is defined. Since this is still a very early and primitive prototype, we still have many improvements that we would like to make, and after discussing our strategy with our sponsor, we are planning to make use of some of the features found in C++20, concepts and ranges. What you are seeing on screen right now is a slide shared with us from our sponsor Cheyenne that demonstrates what is possible through the use of concepts and ranges. As can be seen in this example, concepts allow you to produce meaningful and concise error messages that give you a clear understanding of what has caused the error. This is a large undertaking that will require some time to complete, and as a result, development of this debug version will continue into the next sprint and be one of our target deliverables for Sprint 3.
Retrospective. We began this sprint with big plans. We wanted to find an alternative to the handles class, or at least alter it to address its main issues. We quickly found that this task, though seemingly straightforward, would actually be quite the headache. The code was very complex. We weren't very sure about the intricacies of how the different parts interacted with one another. We realized we needed to turn to our sponsor to help us. He was able to explain the code, and he addressed the things we were stuck on. He also recommended we create a debug branch so we could see what parts of the code were being run during specific test cases. We learned that communication with our sponsor was important for us to make progress during this sprint, and we'll be more comfortable asking for help during the next sprint. During this sprint, we had many things go well. We divided the work and worked in 2 smaller teams. One team would work on the debug branch, and the other would begin creating the alternative to the handles class. Communication overall was improved, especially when it came to talking with our sponsor. We continued to hold weekly meetings with our sponsor, and we held nearly daily meetings amongst ourselves. There was also greater use of the Kanban board. We still wanted to add in more test cases for debugging, and we'd like to add more documentation, specifically better meeting notes and more use of the Kanban board. We plan to change a few things in the next sprint period. Again, we'd like to improve documentation after meetings and within the Kanban board. We also plan to hold fewer but more regular team meetings. At the moment, we tend to plan meetings 1 or 2 days before they happen. Instead, regular agreed upon meetings would be much better for all of us. We'll continue with our 2-group method, getting a better grasp of our roles within our subgroups, and we plan to have both groups work together more closely in the next sprint. We plan to improve error handling, and we plan to incorporate features from C++20, including concepts and ranges. Currently, we use an older version of C++ for our code. As a stretch goal, we plan to add automatic documentation via Sphinx, which was recommended to us by our sponsor.